Hello, Active Chemistry. This is Mr. Uy, and I'm going to teach you how to do the lab for Section 2, Elements and Their Properties. Today we're going to be focusing only on 9A, 9B, and 9C. A couple of things before we start this endeavor. You're going to be responsible for all the sections. The what do you see cartoon caption, what do you think, which is asking you what is an element. The investigate portion, only 9A, 9B, and 9C. And what do you think now? First off, we've done the first part of this, which is comparing metals versus nonmetals by doing the same tests that we did in the previous chapter when we did our movie special effect. We focused on metals versus nonmetals. We did things like conductivity, malleability, luster, etc. That's the same exact thing for this chapter. So rather than repeating ourselves, we are going to be driving on and just focusing on oxides and elements. That's 9A, 9B, and 9C. So what are we testing for? Well, we're testing for pH. pH is a way to measure whether a solution, or an oxide in this case, is an acid with a pH level of 1 to 7, or a base with a pH level of 7 to 14. What we're going to be testing for are oxides. When oxygen reacts with certain elements, they form oxides. Most oxides of metals will produce a basic solution, whereas non-metal oxides will produce an acidic solution. So it's a handy way to really show whether or not an element is an acid or a base. In the book, it says to use universal indicator, but we are going to be using pH paper. So here's your tray setup in each group. Each group is going to have one of these trays with all the equipment that you need in order to start this lab. Each group is going to have a tray of materials, and I expect it to be the same way it was when you first get to your stations. Please be respectful of other groups using this the period after you. And your materials are, you're going to be using distilled water in a distilled water bottle. That is to dilute the solid samples in powder form into a liquid sample that you can test pH with. Okay. You're going to be using the test tube rack to house the 8 test tubes. Tweezers to take the sample in microscale and put it in the test tube. Pair of scissors to cut the pH paper in thirds. And of course pH paper in strip form. I want that pH paper to be a little bit smaller so that we can conserve on using it. I want you to take your oxide samples from the center demo table. There are 8 samples. These samples are aluminum oxide, carbon dioxide, copper oxide, iron oxide, etc., etc. And of the 8 samples, the only one that is in liquid form already is the carbon dioxide. We're going to be using Perrier water. So you only need a small sample of that to place inside your test tube and do the pH test in. You're going to take 8 small test tubes from the supply table and place it inside the test tube rack. We are reusing them after each period. So at the end of the period, I expect the test tube racks to look like this. Wash the test tubes well, rinse them off, and let it air dry. It's fine. So cut the pH paper. If you notice, the pH paper vial has the key so that you can read it. Based upon color changes will determine what pH level it is. I believe 14 is greenish, while pH 1 is magenta. Anyway, you are going to take that long strip. We're only going to need a smaller amount of it, so that's why you are cutting it in thirds. Cut the pH paper in 3 pieces and make it as equal as possible. You should come up with a size like this. Large enough to be able to hold with your tweezers, but small enough so that we can fit it inside the test tube. Remember, we're thinking microscale. Use the tweezers to take a sample of the oxide. Keep it tiny. Less is always more in this case. And then I want us to take that sample, put it inside the test tube, and fill that test tube with about yay much water. Not really that much. Roughly about a centimeter long. Fill it with water and mix it up. And after you mix it really well, dip the pH paper to sample it, and then read it by using the vial. Think microscale, guys. Read the color level and make a note in your lab write-up. Just remember that a pH of 7 or less means that the element is a nonmetal. Greater than 7 means that the element is a metal. This is a handy way of verifying whether or not an element is a metal or nonmetal. Alright guys, so I will see you all on Friday. Please be nice. Please be well behaved for the sub. And Jake, I'm watching you. Thank you.